I'm Anil Kumar sharing with you how to write differential equation when circle is given to us as family of curve with different conditions. The whole idea is to practice few examples of similar kind in one set of videos so that you can easily write differential equations for any given function. So look at all my related videos on differential equations to master this technique. The equation here is, find the differential equation of all circles, and these are 5 different conditions. Let's go through them one by one. First one says, touching the x-axis at origin. What does it mean? So it really means that, I could sketch it here, circle touching the x-axis at origin means something like this. So that is a circle which touches x-axis at origin. We could make another circle which could be kind of like this, right? So this is also a circle touching the x-axis at the origin. Now what you see here is that if we consider the center of the circle, then radius and the center y value is same, correct? So in this particular case, the center could be taken as 0 for x value and a for y value. If you take that as your center, you can write down the equation of the circle as x minus 0 whole square plus y minus a whole square, radius being a is equals to a square. Do you get an idea? So the family of curve for which we are interested is kind of like this, where you can see there's one parameter. One parameter means we are looking for a differential equation, ordinary differential equation of order 1. Perfect. That is what we're looking for. The next example here is touching the y-axis at the origin. So instead of x-axis at the origin, this time the circle is touching the y-axis at the origin. So tangent is y-axis, not the x-axis. Here the tangent is x-axis. So for part B, we are looking for circles which are kind of like this. You get an idea, right? So they are slightly different circles and will definitely have different equation, and we'll see how to find differential equation for these. Now in this case, the center changes. Now the y value is 0, center will be at a0, correct? And therefore the equation of this circle will be x minus a whole square plus y minus 0 whole square equals to a square. This is also of order 1 since we have only one parameter here, correct? Part C is we're talking about a circle in the first quadrant touching the coordinate axis. That means both x and y. But all the circles are in quadrant 1. So in this case, condition is something like this. We have a circle which is kind of like this. Both x-axis and y-axis are tangent to it, right? So the center now will be AA, perfect? So that is going to be the center. So in C, we could write equation of circle as x minus a whole square plus y minus a whole square, which is also equals to a square, right? Now let's look into D and E. Having center on line x equals to 1 and radius 2. So that means we're talking about having center on x equals to 1. So let me just sketch a x and y coordinates like this. And we want line on x equals to 1. So that is the line, x equals to 1. Do you see that? So on this line, anywhere the circle could be, correct? So that means x value is 1, right? So y value is changing, the x value is constant. Is it okay? So we could write this as x minus x value will always be 1 square plus y value changes. So y will write this as 8 this time. Y equals to a square. And we are given a radius of 2. So that will be 2 square, which is 4. You get an idea. So again, we do have a circle whose equation is kind of like this. Radius being 2 means that, let's take a point which 2s radius. So let me make a circle here. So it will be kind of like this. Okay. So what we're saying here is this point is let's say 1, 2 for us. Is it okay? This particular circle has 1, 2, but I mean, and therefore it touches, and therefore this is like at 2. However, we could have circles where the value in general will be a value is 1, but I mean x value is 1, y value is a, and the circles will be, let me draw another circle here. Okay, it doesn't matter. We'll kind of like this, right? So what we have here is a circle with x value of 1 on this line, y value is anything, right? So is anything. So we are just taking this as a, but the radius is 4. So the radius is fixed as, 2. Radius is 2. Okay. So that is what the circle is which we are talking about. Now, part E is centered on the x-axis. So it is centered on the x-axis. Let's sketch this also. With fixed radius, correct? With fixed radius. So that means radius is varying. So we could have circle like this, right? So anywhere on the x-axis, since that value a is changing, well, y value will remain as 0 in this particular case, correct? And the radius also changes. So center is here. So you could have any circle. I mean, even this will work, right? Center on the x-axis. I'm sorry, I made this bigger. Radius is constant. R is constant. So we have to maintain the same, I mean, kind of like this. You get my point, right? So this is not correct, but that is correct. So what you see here is that as far as the y value is concerned, that remains 0 along this line. The center will be a and 0. However, the radius is fixed at capital R, right? So that is how it is different from the first case where radius is a. Perfect. Anyway, and R is also a constant. So we can follow a similar method. So what we have here is x. So a value is changing. I'm sorry, like this. A value is changing. The x value is changing. The y value remaining same, which is 0. And the radius is r, so it will be r square. So what you see in all these cases, that in all these cases, we have only one parameter to work with. So we are looking for ordinary differential equations with order of 1 to represent all these conditions. I hope this point is absolutely clear. You can now work on these equations and get the differential equations relating each family. So let's start with the very first one, which is find the differential equation of circle touching x-axis at origin, right? So x-axis at origin, so let's make a small sketch here. So they are touching like this, right? So we could make a, let's make a smaller one, kind of like this. So in this case, what we see is that the equation could be written as x minus, since on the x-axis the value of x is 0, minus 0 whole square plus y minus a whole square will be equals to a square, since y value will become the radius of the circle, correct? So that becomes the equation. Now to solve this, let's actually open this bracket. So we have x square plus we have y square minus 2ay plus a square equals to a square. They cancel out. So we have x square plus y square minus 2ay equals to 0. Now we have only one a here we can eliminate. by differentiating with respect to x. So we get 2x plus 2y derivative of y prime minus 2a derivative of y prime equals to 0. Now from here we can find what a is, right? So cancelling all 2's, we are left with x plus y prime equals to 2ay prime, and therefore a is equals to x plus y prime divided by, I'm sorry, 2's we cancel, right? So 2's we cancel. Let me cancel them properly. So divided by 2, this is what we get. So we have ay. So now this gets divided by y. So that's the value of a. We can substitute this value in the simplified form and then get the result. So now the differential equation will be, substituting here, we get x square plus y square. Let me write first this as equals to 2ay. So I'm going to substitute a here, and I'm going to do it on the right side. We'll get more room to work. So I'm substituting a right there. So we get x square plus y square equals to 2 times the value of a is x plus y prime over y prime. Got it? So we can now multiply and then rearrange. Correct? So we get x squared y prime plus y square y prime equals to 2x plus 2y prime. So we substituted a, but I forgot to multiply by y. So that is a mistake I did. So 2ay, so 2a is this. I have to multiply by y. So let me write here y here, right? So 2ay. So when I multiply by y, I get here 2xy, and here I get 2y square. Correct? So we forgot this part. That is to say, we substituted a, but we forgot y. So I'm doing that now. So now we can rearrange. We get 2y square y dash, and here we have y square y dash. So bringing them together, we get x square y dash plus y square y dash minus 2y square y dash. We could take this on this side or keep it there. It doesn't really matter. Okay. Now this gives us x square minus, we'll take y dash common, and from here we can write down, okay, let's do 2 steps. Okay, x square y dash, and this gives us minus y square y dash equals to 2xy, or we get x square minus y square y prime equals to 2xy. Correct? So that becomes the differential equation representing the given scenario. Okay, so I hope that is absolutely clear. And now let us take the next example. Now in this case, we need to find differential equation of all circles touching the y-axis at origin. So we could sketch the family of curves kind of like this. We have one circle like this touching at origin, right? And let me draw a smaller one now. Let's say touching the origin, kind of like this. Okay. So what you notice here is that the center is going to be with y value of 0. So the center is now at a0. Radius is a. Therefore, we can write the equation as x minus a whole square plus y minus 0 whole square equals to a square. Now the steps are exactly similar to what we did last time, so you can always pause the video, answer, and then look into my suggestions. So now we get x square minus 2ax plus a square, and here we have plus y square equals to a square. These two cancel. So we have x square minus 2ax plus y square equals to 0. Now we are going to take derivative with respect to x, correct? So we get 2x here minus, this is 2a. Derivative of y square is 2y y prime equals to 0. We can isolate, first let's cancel all these 2's. So we get x minus a plus y prime. And now we know what a is. So x plus y prime is equal to a, correct? So we know the value of a. So we can substitute this value of a in this equation, correct, which we differentiated. So if I do that, what do I get? So I get x square minus 2. So let me write x first. We'll write then the value of a, which is x plus y prime, and we have plus y square equals to 0. So let's expand this. We have x square minus 2x square plus, minus 2y y prime plus y square equals to 0. So this gives us minus x square, right? So we have minus x square, and here we have minus 2y y prime plus y square equals to 0. And then we can actually take it to, we could write this as, let me write down here. We could write this as y square minus x square equals to 2y y prime, correct? So that becomes the differential equation, which is going to represent these circles which are tangent to y-axis at origin. So I hope the steps are absolutely clear. Now let's move on to the next question. Now we need to find differential equation of all circles in the first quadrant touching the coordinate axis. So the scenario is kind of like this. You have circles here which are touching the x and y axis. So this time I'm redrawing with first a circle and then the coordinates, correct? The situation is kind of like this. Now in this situation, what you notice is that the center will be at AA. Radius is also a, and therefore we can now write the equation of circle as x minus a whole square plus y minus a whole square equals to a square. Since there is only one parameter, we need to differentiate only once to get the differential equation. So we have order 1 differential equation. So let's differentiate it. So we'll find the derivative with respect to x. So here we get 2 times x minus a plus 2 times y minus a, derivative of inside function y prime equals to 0. Now we need to isolate a from here. We can always cancel 2, so we are left with x minus a plus y prime minus ay prime equals to 0, dividing by 2. Getting these a's together, we can write x plus y prime equals to, taking them to the right side, a common, 1 plus y prime, correct? So a is equal to x plus y prime divided by 1 plus y prime. So that becomes the value of a. Now we are going to substitute this value of a here to get our differential equation, right? That's the whole idea. That is the value of a, x plus y prime over 1 plus y prime whole square plus y minus all this, which is x plus y prime over 1 plus y prime whole square equals to square of this, x plus y prime over 1 plus y prime whole square, right? So you get this equation. Now we can multiply all these terms by 1 plus y whole square, so that gets cancelled. So before that we can multiply it here. So we get x times all this. So we get x times 1 plus y prime. Let me maintain the brackets. Plus, and we have minus x, let's write in brackets, plus y prime whole square. Plus we have y times 1 plus y prime minus x plus y prime whole square equals to x plus y prime whole square. Okay. Now here we have x minus x, which cancels, and then we have x y prime minus y prime. So this portion we could write this as y prime times x minus y whole square. Now here we have y times y prime. So y prime cancels in this area. So we get y minus x. So we have plus y minus x whole square. And this is equal to x plus y prime whole square. Okay. So that's what we get. Now x minus y minus x, they are the same terms since both are squared. Is it okay? So you could write either ways. And so what we get here is x minus y, let's say whole square. So that is common. And what we get here is y prime square minus 1, because we took this square as common. Y prime plus 1, this is plus 1 equals to, here we get x plus y prime whole square. So that becomes the differential equation, which is the required differential equation in our case, right? So that is how we can actually find this answer. So since this does not have any arbitrary constant or parameters, we can treat this as our differential equation, ordinary differential equation for the given situation. So you understand that the strategy is to differentiate and then eliminate the arbitrary constant. So let's move on and take the next example. We have already done 3 examples based on finding differential equations for given circles under different conditions. Now here in example number 4, we need to find differential equation of the circles having center at line x equals to 1 and radius of 2. I'd like you to pause the video, copy this question, answer, and then look into my suggestions. Now I will actually give you outline of the strategy. You may have to simplify and get the final answer. So let's see how the circles should look like. We need to find differential equation of all circles having center at the line x equals to 1. So when we say x equals to 1, then basically it is a vertical line where the value of x is 1 for all values, right? So this is 1. So, and it has a radius of 2. So that means if I have, let's say, center here, my x value is going to be 1. However, the y value is, we can take that as a. So that becomes the coordinate. Now in this particular case, we are already given radius of 2. So r is fixed. So let us say that is the radius of 2. So we may form a circle kind of like this. Right? So all the circles with center on this line x equals to 1 meet the criteria. So basically you can see something like this, right? So, well, you get an idea. So those are the circles which we want to represent with the help of a differential equation. Now we know center is 1a, And therefore the equation should be x minus 1 whole square plus y minus a whole square, which is equals to radius square. Radius is 2. So we can write this as 2 square. We get our equation. Now in this, we have only one arbitrary constant, and therefore we are expecting ordinary differential equation of order 1. So let us differentiate it with help of the independent variable x. In that case, what do you get? You get 2 times x minus 1 plus 2 times y minus a times derivative of y, which is y prime, and 2 square, which is 4. Derivative of 4 is 0. That's what you get. Now we need to eliminate a. So from this particular equation, we can actually find what y minus a is, right? So first let's cancel these 2's. So we are left with x minus 1 plus y minus a, y prime, which is derivative of y. You can write dy dx. Now from here, we can say that let's take this to the other side. So we have y minus a times y prime is equals to minus x minus 1. And y minus a will be equals to minus x minus 1. Let me write it in brackets, divided by y prime. Now I can substitute this value here for y minus a. So, and then we can actually eliminate a, right? So y minus a, I can substitute that. This will result into the equation x minus 1 whole square plus, instead of y minus a, I'm going to write all this, which is minus of x minus 1 y prime whole square equals to 2 square, which is 4. You get an idea. So that's the differential equation. Now it is always a good practice not to write this in denominator, right? So let's multiply this. So we can write this as x minus 1 whole square y prime square, right? That is this square, plus this becomes positive, so I can write this as x minus 1 whole square equals to 4. And of course, and then we have to multiply everything by y dash square, so it is 4y dash square. Yeah, good, I saw this. So we actually took this out from the denominator, multiplied every term by dy dx whole square to get this. So that's the answer. You could always rearrange, simplify. You do see x minus 1 a common term. So I'll leave it here for you to simplify. So let me write here, simplify, and write your answer. But what you notice here is that we got order 1, and what is the degree? Degree is 2 for this ordinary differential equation, correct? Now let's take the last example, which is find the differential equation of all circles centered on x-axis with radius r. So in this particular case, we are given a fixed radius, right? So all will have kind of same radius. Okay, and they are all centered on the x-axis. So we're talking about some circles like this, right? So circles like this we're talking about. Now if you want to figure out what is the center of any of these circles, y value is going to be 0. So it could be a0, for example. So a becomes our arbitrary constant. The radius is capital R. So this is capital R. So we could write this equation as x minus a whole square plus y minus 0 whole square equals to capital R square. Since there is only one parameter, we'll actually differentiate once, eliminate it, and write our equation. So differentiating, we get 2 times x minus a plus 2 times, this is just y, right? Y prime equals to 0. From here we can find what x minus a is. So x minus a is equal to minus y prime, correct? So cancel 2's if you want to, or you can say divide by 2. Taking this on the right side, we get minus y prime, that is x minus a. So let's substitute it here in our original equation. So we get minus y prime whole square plus, that is y square, equals to r square. Now that gives you, that becomes positive now. So we get y square, y prime square plus y square equals to r square. You can always take y square common and then rewrite, or you can write it as such. So anyway, we do get a differential equation here where there are no parameters, and this differential equation represents all the circles whose center is on the x-axis with radius capital R. So in this particular series, you solved, I should say, you wrote equations, differential equations for circles with given conditions. So I hope that helps. I'd like you to go through my other videos where we are talking about series on separate topics that should help you to master the technique of finding differential equation for given function. Feel free to make your suggestions. Your suggestions are very valuable. If you like and subscribe, that'll be great. Thanks for watching and all the best.